30 is used, 30% is used for testing, 70% is used for training. Okay, I can also use tenfold cross validation. So in tenfold cross validation, what will happen is the first, okay, if you see here, I have printed the names, I have printed the values obtained by local binary pattern, and I see the histogram something like this. This is the code what I showed you previously. What I showed you previously in the previous session, I was showing you this code. So now you're looking at this. Can you just hold on for a second? I have a important call coming in. Hello. Hello. Sorry, that was an emergency call which I had to take. Okay, so what is it we understand from this? What is it? Can somebody try to read the histograms that has been created on the features? Can somebody try to understand and tell me what is it that we are seeing? For the normal image, we see that this is highly skewed. The data is highly skewed. Even for the abnormal image, the COVID image, the features extracted are highly skewed. If you see the values, the frequencies are very high for range of up to 200. Beyond 200 till say about 600, they are present. After 600, it is very, very sparse. The data is extremely sparse. The same case here, maybe up to 500, 550, I am able to see the data. After that, it becomes extremely sparse. So my question is this positively skewed or negatively skewed? Can somebody answer this question? Is it positively skewed or negatively skewed? We learned this in the morning. Make mistakes, not a problem. The body is on the left hand side. So no, is it positively skewed or negatively skewed? Now, if I give this, they are positively skewed because no, the values are on the lower side. So the data, they are all positively skewed. Now, if I give this to any algorithm, it will fail miserably. Maybe the best case scenario could be a decision tree algorithm. A decision tree algorithm performs fairly well. Reason being very simple. The decision tree algorithm is resistant to noise. But now I cannot take a decision as whether it is noise or whether it is data. We need to identify that and from there take it forward. Okay. So at least from the graph, we are able to see that it is positively skewed. The range is very small between 0 to 200, but I also see values till 1200. Being X-ray images, there is a good chance that this data may, may be susceptible to a high amount of noise. Okay, so we'll go to the next slide and look into the statistics. Okay, I'm giving you the statistics. I'm also plotting the scatter plot. So if you see the scatter plot, on the x-axis, I have the normal image. On the y-axis, I have the data of the COVID. So I see my mean, normal and abnormal, almost the same. Median, same. Skewness, see that, 5.54, 12.81. That means I cannot apply any of my regular machine learning algorithms other than maybe decision tree algorithms. See the kurtosis. Kurtosis is positive and 45 and 231. That means kurtosis has, it shows that this curve is a leptokurtic, very sharp peak, leptokurtic with heavy amount of tails. We need to see how to get this. For me, typically my skewness should be between -1 to +1. Then I can apply most of the machine learning algorithms irrespective of their strength and weakness. I'm able to see my quartile 1, quartile 2, quartile 3. That is my 25th. No, my 25th value is about 26. The location of the 25th. Here it is 18. The largest value for the normal is 1325, whereas for this it is 3320. The standard deviation is also extremely high. So looking at this data, I need to do some sort of data cleaning. Now, what I have done is I have also calculated the 5th percentile and the 95th percentile. The 5th percentile is 3, whereas here it is 0.63, the 95th percentile. That means in a class of 1000 students, of the 1000 students, 950 students have scored less than 186. 950 students have scored less than 182. It's only the 50 students who have scored more than that. So, do you have any suggestions as how to take this forward? What can we do to solve this problem? We know it is highly skewed. I don't want a skewed data because my algorithm will not perform well. No point in beating around the bush. That is why the original authors in Nature also have used a modified convolutional neural network. So can somebody suggest how to take this forward? Is there a solution? Is there a method to the madness? Can somebody suggest? Karpaga Priya?
Sir,
Yeah, can you give me a solution?
sir, I have a doubt actually, sir. Actually, like when you're calculating for 5th percentile, we have a drastic difference, but we are going with the 95th percentile. Why we are having only a small amount of difference over there, sir? Is there
See,
any
yes,
thing we are going to?
no, are you talking between the normal and the abnormal, or are you talking about the normal and COVID, or are you talking about the 5th and 95th?
So here we are showing normal and abnormal, sir.
Okay, yeah. When comparing between normal and abnormal, the 5th percentile has 3.09 and here the 5th percentile has 0.63, whereas the 95th percentile are the same. Am I right?
Yes, sir.
Okay. Let us look at this scatter plot. Look at this component. All these components can be assumed to be noise, being an X-ray. That means if I state that if I make a hypothesis or if I make an inference which very clearly states that A COVID X-ray has lot of lower histogram values compared to the normal X-ray when our local binary pattern is used. Can I make an inference? யோசிச்சு பாருங்க 600 குள்ளதான் most of the values are lying here. இங்க கொஞ்சம் இருக்கு, we have some data here, let us not bother about it. Within this, if it is a COVID image, the values are still lower. Whereas no, as the values become higher and higher, they are almost the same. So can I make a strong assumption that the value is the COVID or the normal chest X-ray can be identified at lower values? Can I make a strong assumption?
Yes, sir. Yes, sir.
Okay, very good. I am making that. Now, yes, instead of the 5th percentile, can I take the 2nd percentile and then 98th percentile? I will not leave it. I am seeing that lower value la வந்து indicators irukku, COVID indicators irukku. So maybe I'll take the 2nd to 98th percentile. There is no hard and fast rule. Confidence interval 5th la irundhu 95th kulla irukanum, there is no rule at all. As a data scientist, you frame the rules. So here I'll frame the rule, that between 2nd and 98th percentile I'll take the data. So what I'm doing is I'm using something called as a trimmed mean. Trimmed mean means removing all the data on the lower boundary and the upper boundary and having that data, because now I'm assuming they are outliers. It's an assumption which I'm going to make and I'm trying to prove it. See how beautiful the data is. Okay, if you see, it's a perfect box. If you see, it is a perfect, though it is skewed, it is still a beautiful normal curve. Now I need to check whether it is a normal distribution or a abnormal distribution, non-normal distribution. So what I'll do is, I will do the statistical check again. I don't have the statistical values. Okay, I don't have the values with me. I missed it somewhere. Okay. Let me see. So, but however, I remember the values. The values were between -1 to +1. The skewness was between -1 to +1. Let me know. Just check whether I can get that. Kindly hold on. Okay, are you able to see the new screen? Are you able to see the descriptive statistics? Yes or no?
Yes, sir. Yes, sir.
Okay. So what has happened in the previous slide? I think I'm showing you my bits planning slide, not a problem. In my previous, the mean was about 67.3, 67.387. The median was 47.42. The skewness was 5.5, 12.87. My skewness has become 1.06, 1.04, almost a normal. My curtosis has also become positive, 1.269, 0.76. That means, this very strongly states that the number of outliers or the tail which was very heavy is no more heavy. I am just showing the 5th percentile now as 7.14. It was 3.6 something. My 5th percentile has become 1.78 instead of 0.67. My 95th percentile has also come down. So what I'm getting is a very beautiful normal distribution. So it is not skewness is not there. But again, now I'm seeing it here and I'm validating it. Now, I want to do one more test. Now I have a problem. Should I use a logistic regression? Should I use decision tree. For this case, generally, as a rule, you can say whenever you have a class label which is binomial, bimodal, then logistic regression works pretty well. But here, the conditions satisfy for decision tree, they satisfy for logical regression, they also satisfy for neural networks, they satisfy for deep learning networks also. Okay, so if you look here, what is it? No, we are trying to identify. We have cleaned the entire data set. The entire data set has been cleaned and it is ready for the machine now. It is ready for the classification algorithm. It is ready for the feature selection algorithm. Okay. And if required, I can do data transformation, which I have not done. I could have done a data transformation so that you can have it between 0 to 1. I want to find certain things. Lot of classification algorithms do not prefer the data to be dependent with each other. If the features are dependent with each other, then my algorithm does not perform well. So since it is a continuous data, I'll have to use the correlation coefficient to find out. Okay, so we'll understand more on correlation coefficient before getting into the algorithm. So maybe let me just go back to my previous slide. Okay. So in the first example in the morning session, we were seeing something about cigarettes, right? You are able to see my screen? Yes or no?
No,
Are
sir.
you, okay, are you able to see now? I hope you are able to see now, right? Karpagapriya, are we able to see it?
Yes, sir. Yes, sir. Yes, sir. It's visible. Yes, sir.
I'm just taking another example for you all to understand how correlation, because correlation plays a very critical role. We call it as multicollinearity. That means, if two dependent variables. See, what is dependent variable? What is my independent variable? For the COVID data, the features extracted are called as the dependent variable. The class label stating whether it is a abnormal or a abnormal, normal or a COVID X-ray image becomes the dependent data. So you have this independent data. Based on this independent data, you are trying to predict the dependent data, which is also called as the class label. Okay. Now, one condition that we really need to look at is multicollinearity. That means my correlation should be as low as possible. That means the features have to be independent. How do I do that? Well, let us take a very simple example to find whether two things are correlated or not correlated. Here, what you see here in the screen is the data that was used showed in my previous example. We had something called we had a ordinal data, smoking, right? Here I have the variable. I have the variable number of cigarettes smoked and the lung capacity. Now, What is it I see? When I do not smoke, the lung capacity is high. If I'm smoking less than 5 cigarettes, less than or equal to 5 cigarettes, the lung capacity is slightly decreasing. But if I'm smoking between 6 cigarettes to 10 cigarettes, less than or equal to 10 cigarettes, my lung capacity falls down. And after that, it is a smooth fall. So maybe I plot this. I plotted this for a very simple reason. In the previous session, the data was ordinal. Now I want to convert that data into categorical. How will you do this? See, based on the data, you should tell me how will you do it.
Whether he is a patient of lung patient or not, lung cancer.
Sorry? Yeah, it is
Based
a,
on the lung capacity, we can decide whether he is a lung cancer patient or not a lung cancer patient.
it is not lung cancer. There we are talking with respect to a heart attack.
Yeah,
So
maybe okay.
yeah, we want to find whether I can convert this data from ordinal to categorical. How was it converted? Initially, it was interval data, correct? Or no, it was not even interval data, ratio data. So the patient comes to me, I ask how many cigarettes do you smoke? He'll say, I don't smoke, 0. Somebody comes and he'll say, I smoke about 5 to 7 cigarettes. I'll put it as 6. Then somebody else comes, he tells, I smoke about 15 to 16 cigarettes. I'll put it as 16 or whatever it is. I have this data that I converted into ordinal. This is nothing but a ratio data. Why is it I'm calling ratio data? Because a non-smoker means 0 cigarettes. Then, now I bin it. I am using a binning technique. 0 to 5, no, less than or equal to 5, 6 to less than or equal to 10, and so on and so forth. Once I do that, I can rank it, I can call it as ordinal data. No smoker, occasional smoker, 5 to 10 cigarettes. So it becomes a ordinal data. Now I want to convert this into a categorical data. Okay, look at this data and try to tell me how will you convert this into categorical data. These are the research questions that you need to handle. Can somebody look at it and tell me? Somebody tell me. Can anybody comment on that? Look at this. Because now as a researcher, as a decision maker, which the machine may not be able to do, how do I convert this into a categorical data? Can you see the way the graph is going? It is almost linear. I'll draw a line here. Can we try stating that for predicting heart attacks, if the person smokes less than 5 cigarettes, it is not an indicator. Whereas if the person is smoking greater than 5 cigarettes, the lung capacity starts coming down. That means physically, if the person is smoking less than 5 cigarettes, he is not getting he may not get a heart attack because of that, because of cigarette. Whereas once he starts increasing, the lung capacity keeps going up, keeps coming down, and there's a good chance he might have an heart attack. Now I want to find whether both are correlated. Okay, whether they are correlated. Is there a relationship between these two? Okay, so the one way method of doing it is using the covariance. Okay, so covariance talks about the data. It talks about, here I am assuming it is a sample. That is why I use standard deviation of xy. Or else I would have used, the symbol. Okay. Since it is a sample, I'm using 1 divided by n minus 1, or else I'd have used 1 by n. So don't worry about it. Xi minus x bar into yi minus y bar. That means the value minus the mean. So I can try seeing what is the outcome. My mean here is, what is my mean here? 35, 45, 50. 50 divided by 5. My mean is 10. So 0 minus 10 is 10, minus 10. 5 minus 10 is minus 5. 10 minus 10 is 0. 15 minus 10 is 5. 20 minus 10 is 10. Similarly, I do for y minus y bar, lung capacity. Xi, then I multiply both of it. Minus 10 into my 9 is minus 90. I get the summation. Okay. So 1 divided by n minus 1. I do the computation. Okay. 1 divided by n minus 1. So 1 divided by 4 into minus 215, which is minus 53.75. This indicates they are correlated, but they are negatively, they have a covariance of negativeness, negative covariance. That means when the number of cigarettes is consumed is higher, the cigarette smoked here, no, the lung capacity keeps coming down. That means one parameter is increasing, the other parameter starts coming down. That is what this indicates. But however, interpreting this number is slightly difficult. So the more popular component is using the Pearson's correlation, which has a range of -1 to +1. So Pearson's correlation is the covariance only, but it uses the z-score. It uses the z-score instead of the values. So what did we see? The z-score as z equals x minus mu by sigma. We saw that previously. Now, if I look at it as a formula, this is what I see. Summation of xy minus of summation x minus of multiplied by summation y divided by summation of x squared minus of summation x whole squared. What does this mean? Let us say x, y. I have 2, 4, 3, 5. Okay. Total here is 5. 2 plus 3 is 5. 4 plus 5 is 9. Right? Now here it says summation of x squared. Summation of x squared is, x squared here is actually 4, 2 squared is 4, 3 squared is 9. Summation of x squared is 4 into 4 plus 9, 13. N is 2. So 2 into 13 minus summation of x whole squared. What is summation of x? Summation of x is 5. Minus summation of x whole squared is 25. 5 squared 25. So 26 minus 25, which is 1. Similarly, you can do for y squared. Okay, here when you see summation of xy, that means what I am trying to tell in the numerator is xy is 2 into 4 is 8, 3 into 5 is 15. You know, sum of this is 23. So summation of xy is 2 into 23. Whereas summation x multiplied by summation y is 5 multiplied by 9. Summation of x is 5, summation of y is 9. So here it will be 5 multiplied by 9. Okay, so you apply this formula. We can do that. No, I'm doing the summation of x, summation of, I'm doing xy, x squared, y squared. I apply the formula and I get a value of minus 0.9615. What does this mean? This means they are highly correlated. Okay, the data is highly correlated. It is negatively correlated. The data is negatively correlated. When I say negatively correlated, it means when one factor is increasing, the other factor is decreasing. No, when one variable is increasing, the other variable is decreasing. Got it? Give you a simple example. Let us say you have a shop, a tea shop in Uti, a very cold place, or no, in a very cold the climate is extremely cold. Now the shopkeeper sells 3 items: cool drink, coffee, and biscuits. Now, based on the climatic condition, he sees some observation. Whenever the temperature increases, cool drink consumption increases. Whenever the temperature increases, coffee consumption decreases. So I am at temperature increasing, cool drink also increases, coffee decreases. Whenever the temperature decreases, cool drink consumption also decreases, coffee consumption increases. Whereas whenever temperature, whether the temperature is high or low, whether the temperature is high or low, there is absolutely no change in the consumption of biscuits. That means a person comes to the shop, he is not bothered, irrespective of the temperature. If the temperature is very low, he orders coffee and then eats biscuit. If the temperature is high, then he orders cool drink and then eats biscuit. So I am getting a beautiful value, minus 0.9615. Now, very much similar to your descriptive statistics, I would like to understand. In descriptive statistics, we saw how skewness, how you can imagine a normal distribution using skewness alone. Here, using the value of the Pearson's correlation coefficient, I can try to find whether they are correlated or independent. You need to know how to analyze. The standard thumb rule is, if I have the value between minus 0.75 to minus 1 or plus 0.75 to plus 1. If the values are between minus 0.75 to minus 1 or plus 0.75 to plus 1, then they are stated to be highly correlated. So here the value is 0.9615. So they are highly correlated and they are negatively correlated. Now to understand this negatively correlated, whenever the the number of cigarette smoking is increasing, the lung capacity is decreasing. That is why you got a negative value. Now, if you take the cool drink, temperature, cool drink and coffee example, whether temperature and coffee are positively correlated or negatively correlated. Temperature and coffee, are they positively correlated or negatively correlated?
Negatively correlated, sir.
Negatively correlated. Why?
As your temperature increases, the coffee consumption will be decreases.
Perfect. Excellent. So, what about temperature and cool drink?
They are negatively correlated, sir. As positively correlated. When the temperature increases, the consumption of cold drinks will get increased.
What about temperature and biscuit?
Actually, they are static, so they remain constant. So the correlation.
Yeah, they are no way related. We can call them as independent.
Independent.
They are
Okay.
not correlated. We can call them as independent.
Okay.
But the golden rule that you need to understand is, if the value is between this range, then not a problem. Similarly, if the value is between minus 0.25 to plus 0.25 or minus 0.3 to plus 0.3, we'll call them as independent. That means when the temperature is increasing or decreasing, there is no relationship between coffee or cool drink with respect to temperature. They are highly independent. The third scenario is where we see that it lies between minus 0.3 to minus 0.75 or plus 0.3 to plus 0.75. This is the case where it is weakly correlated. Again, if they are independent, happily you can use that in your data set. If they are highly correlated, I don't want to use them in the data set. I can eliminate one of it using one of the feature reduction techniques. But if they are neither, if they are weakly correlated, that is neither independent nor highly correlated, what should I do? This is where your machine will not be able to tell anything. This is where setting the parameter becomes very important. I gave you this rule, minus 0.3 to plus 0.3. But if your work requires high non-multicollinearity, then maybe you can change the parameter from minus 0.4 to plus 0.4. Or this can be your research for the COVID problem itself. You can say the Pearson correlation coefficient value is non-deterministic. அப்படின்னா என்ன சொல்றோம்? கரெக்டான வேல்யூ வந்து டியூன் பண்ண தெரியல. That is a parameter that has to be tuned. And you create a hypothesis. Performance, there will be no performance improvement if the optimal correlation coefficient is identified. Null hypothesis. Alternate hypothesis, there is a strong relationship between the parameter value, coefficient parameter value, and outcome. Again, this becomes your research problem. If you are able to find the optimal value, maybe it is bounded between 0.3 to 0.4 or 0.2 to 0.5. Let us not bother about it. You are giving the upper bound, you are giving the lower bound. Based on this, automatically that becomes a research problem. Since it is a non-deterministic polynomial problem, we have to use heuristic methods, or to be more precise, meta-heuristic techniques. Foundation being genetic algorithm, and that is something where you can do a lot of research. So when you saw in the title, a tailored deep learning network, it meant that the hyperparameters are optimized. Anyway, it is not the scope here, but now I'm just giving you an example how it happens. Now, we saw Pearson's correlation, but now you cannot use Pearson's correlation when the data is highly skewed. Again, looking from a pure scientific perspective, you cannot use, because the data, the skewness is greater than 5. You should have used Spearman rank correlation. Okay, so we'll go get into the code and also try to see what is it we are getting for two scenarios. Now let me share my new screen. Are you seeing the Python notebook? Are you seeing the Python notebook?
Yes, it is visible, sir.
Great. So now I'll just run through the code again. Now you'll be able to understand. So I'm doing all the imports. Load the data set. I have two files. One is called as beforeprocessing.csv, which is the pure LBP data containing 9,440 records. And there are two chest x-rays. One is the normal chest x-ray, the other one is the COVID x-ray. So now I think you should be able to understand it. I am seeing the head of it. I am finding the mean, median data here. Okay, I see that my skewness is high, 5.54, 12.82. So I also showed you the plot. I'm creating the histograms. What you saw, highly skewed. I'm seeing the other histogram, the abnormal, the COVID chest x-ray histogram. I'm seeing the scatter plot, which you already saw. Now, I want to find out the correlation. Okay, I have used the Spearman correlation. I see that the value is 0.618982. Instead of that, I'll try using the Pearson's correlation. Let me run that. I am seeing that the values are 0.5, 0.5, 0.5. But if I apply the Spearman, this is before processing the data. I have not processed the data at all before processing the data. Now, instead of that, I use the Spearman. It improves. I am able to see that the correlation is 0.61, no, which shows there is some sort of relationship, which is a painful thing for me. Why is this relationship happening? Because no, it is loosely correlated. It is not tightly correlated, like having a value of 0.75 to minus 0.75 to minus 1 or 0.75 to plus 1. But there is some sort of correlation which definitely will affect my classifier. So I have the new data set, which I call it as after processing.csv. See, I'm using X-ray underscore after processing equals PD. PD means I want to use the pandas library read CSV file. So read underscore CSV. I have the file name. See, since it is a file name, or it is a label, I'm trying to put it in double quotes. I put the header as none, and column names is the same as normal and abnormal, which I had already described previously. I want to see the data now. I can again look at the head. I can see how much ever data I want. I want to see 100 records. I'm able to see 100 rows, right? I need to keep stretching this out so that I can see all the 100 rows. Let me just change it to 3 records. My default is 5 records. Then I want to calculate the mean, median, standard deviation. Okay. Now, whenever you want to use this, you could have copied and pasted it here. Whenever you copy and paste it, ensure that the names are all unique. நிறைய mistakes பண்றது வந்து இந்த இடத்துல பண்ணுவீங்க. It is where you make coding mistakes. You copy and paste. Now already X-ray before processing is existing. If unknowingly, if you forget to change it, then you are going to have a problem. Okay, you can use the find and replace command, but be extremely careful what you are finding and replacing. I am trying to put that in this cell. So if you are trying to use the replace all, be extremely careful, or else you are going to have problems. Okay, naming convention, copy paste. You can do copy paste, but don't screw it up somewhere. Similarly, here when you're looking at it, I'm looking at the 25th and the 75th quartile. Unknowingly, for giving a demo, maybe I should have done, I would have changed this to 0.05. Or as you're investigating, you would have done it to 0.05. Where else your output will show it as the 25th percentile. These are all common silly mistakes that we do in the research. Okay, because in the rush to complete, we copy paste, and that is where we make mistakes. Okay, now I'll print the commands. I'll print the execute and print it. So I'm seeing my skewness has decreased, my kurtosis has decreased, making it an ideal normal distribution. Correct. Let me also do the plot histogram. Looks so decent, though it may look as if it is non-normal because one particular peak is very high in the histogram. Nothing to worry, it is still showing it as a normal distribution and not a non-normal distribution. I am going to do it for the second image. I see some method to the madness. And I also do the scatter plot where I get a beautiful square plot. Again, now I'll run the Spearman correlation. I get a value of minus 0.033, which is highly independent because it is almost close to 0. But no, here actually I should have used Pearson's correlation. I get almost the same value. Now what happens if I don't use this at all? What is it? Please make an observation and tell me what is this. Normala இதுதான் நீங்க mistakes பண்றது. You will just call the correlation library .corr, you just call it. And it gives you an output 0.031899. You immediately say it is independent. So what is the value you got when you did not pass a default parameter? Can somebody see the observations and tell me? Okay, I'll remove it. Again run it. So what is the default value taken by the algorithm?
Pearson. Pearson.
That is the biggest challenge and the mistake that you make in research. What I'm trying to highlight here to you all is it is not about the function. Okay, this thing is Python is a scripting language, extremely easy to learn. Extremely easy to learn, and today technologies are emerging. What you need to really understand is what is the type of function or the method you need to call. Here, if I had given this, it would have been a Pearson's correlation. If in the non-normal data, if I had done the same thing, it is wrong because I should have used the Spearman correlation. Okay. Fortunately, in this case, it really did not have an impact. If there had been an impact, no, it would have been catastrophic. So, as a data scientist, as a big data analyst, you need to understand where to use what. If you don't use, if you are not able to do that, it is going to be chaotic. And if you are into research, if you are working on a PhD, then this becomes very serious problem. And this is where I was also able to show you how the non-deterministic polynomial problem is stated, how is the null and the alternate hypothesis is stated, how is the fitness function stated. Right, I took the engine example and showed you how it shapes it. Okay, let me run it. I'm seeing, now what I'm doing is I am reading the entire features file. I also have another file called as class.csv, class label.csv. Class label contains 47 outputs, which either tells me it is a normal image or a normal chest ray or a chest x-ray or a COVID chest x-ray. I am seeing the first 10 records, and if you see, it shows 10 into 9,440 records. Okay. Now I can see the head. I can see the class label head. One represents, see, if you see here, this is another area where you make a lot of mistakes. This specific decision tree algorithm cannot accept A and N. I can say 0 is normal, 1 is abnormal. But whenever I use decision tree algorithms, it will not convert normal. If I instead of 1 and 0, if I put 0, A and N or A and C, where A or I could have put N and C. N represents normal, C represents COVID. I could have done that. If I had done that, the algorithm may not run. So these are all small mistakes where you make where you need to debug and take it forward. Okay. So now what I'm doing is I'm assigning two variables, X and Y. X contains the features, Y contains the class label. Class label is the dependent variable which is dependent on 9440 independent variable. Okay. Now I have loaded this. I am splitting the data. I am splitting the data into training and testing. Okay. So if you see here, I am giving test size equals 0.3. So it is a ratio variable where I'm saying 30% of the data has to be for training and 70% for, 30% for testing and 70% for training. I can change this, not a problem. Okay. Then I'm invoking the decision tree classifier. CLF. Now I'm giving a variable called the decision tree classifier. I'm invoking it and I'm training the classifier. I'm training the classifier. I also tell the classifier after training what are the predicted values. Okay, so the y underscore predictor are nothing but the predictors for the testing data. I just run it. Now I am taking only accuracy as one metric, metrics dot accuracy. I can do precision, recall, F measure. No, I can find out the errors. No, or if you are very specific on sensitivity, specificity, then no, that also can be done. I run that. I get a accuracy of 0.533. That means my accuracy is 53.33%, which is way lower. Okay, but if you look into the this thing, the research paper, maybe they have worked on it for quite some time. Okay, here I work for 2 days and I'm getting about 53% accuracy. Again, if you see here, I am blindly calling the decision tree classifier. When we talk about decision tree classifiers, there are a lot of parameters. One is the the splitting parameter, which can be entropy based, which can be Gini based. The depth of the tree. Okay, the depth of the tree after which you start seeing the leaf. These are the parameters which has to be fine tuned. Ninga kudukalana randoma eduthodum. If I just give it as decision tree classifier, then it will take by default the criterion as entropy and the depth of the tree will be 3. And I got accuracy of 0.533. Now let us say I am specifically stating the criterion as entropy, which is the default. I am also stating the depth. Depth equals 4 and so on. The moment I do that, my accuracy is actually coming down. Then what I'm doing is I'm changing the criterion to Gini index. I'm keeping the same maximum depth of 4. I run it. I get accuracy of 0.733. 73.33% accuracy. Now this could be for two reasons. One is overfitting of the data. No need to jump. This is overfitting of the data, or you need to prove why this has happened. Okay. Now here we'll try, start fooling around. Let me change the depth of the tree to 3 here. The accuracy was 44%, 40%. Now the accuracy has become 73%. தயவு செஞ்சு இந்த மாதிரி பண்ணாதீங்க. Okay, so here what you thought, more the depth of the tree, better the output. No, let me change it to 6. Let me see what is the accuracy. It is not changing. Let me change this to 10. The accuracy has come down. Let me change this to 40. 73% again. Okay, let me change this to Gini. So one thing we are able to see is the model behaves very erratically. Reason is very simple. இப்போ வந்து I have used something called as a force brute method. I have taken only two components, the criterion and the depth of the tree. I can select other parameters also, especially if I'm going for ensemble classifiers like random forest. Okay, here what is it I've understood? I can also state this could be my fitness function if I'm taking a research problem. இப்போ வந்து நான் அடுத்து how do I take it forward? No, I have not used a COVID net. I am taking two parameters because I did not go to CNN because you'll require a basic knowledge of ANN, and from there we need to go to CNN. Maybe time will not have the time or the bandwidth. So I just took decision tree. This by itself is a research problem for you because for each type of data set, the depth and the criterion plays a critical role. Alternatively, this is where you can apply, it is a non-deterministic polynomial problem. You can try to find a method wherein instead of using Gini index, you can come with your own algorithm, which again is a decision tree, a new decision tree classifier. That is how all your other algorithms came into picture. Classification and regression tree, J45, C4.8 or J45. Then decision stump. You have so many various decision tree names. Okay, that is something where you can work as far as your research is concerned. Got it? Any doubts in the code? I have done it in a very simple way so that I always believe keep it simple. So we took up a real-time example from one of the top journals. We tried deploying it. But if I am given if I am a researcher working on my PhD, I will take this as a I'll take this as a research problem. I can try to say instead of a COVID net, I can talk of a Alex COVID net, where I can try using Amazon's Alex net, or I can use some other a deep learning network using RNN, deep network. I can keep using multiple parameters, or I can use the same convolutional neural network. I can try to solve the hyperparameters using different techniques. Got it? Any questions here? Any questions here? No questions? Anywhere you have a doubt, questions, you can ask me now. Anybody has questions? But are you able to understand how to take forward your any work? It could be a research work, it can be something related to your transition, but you need to understand that we can take it forward only based on this thing. It can be based only on the data, and if you are not good in basic statistics, if you are not able to create a hypothesis, then you are in the wrong place. Research will become extremely difficult. Okay, and with research being tightened in India, it becomes extremely important for you all to understand the problem, work on the problem. So do not deep dive into Python. Do not deep dive into Python. Start with the basics because it has a cascading effect. The entire project that you work will have a cascading effect. You make mistake in the data, then you can be sure that it is going to continuously screw up the entire project, and at some stage you'll not be able to identify what has gone wrong. Got it? Any questions? Maybe I can try sharing one small work. Now, the challenge would have been slightly different if you had used, the data were categorical in nature and not continuous. We saw that the outcome that we got was continuous in nature. The 9,440 histograms were continuous in nature. Now, what happens if they are not continuous but categorical in nature? That's a challenge that which we need to understand. I'll maybe share a new screen and try to. Just hold on for a minute. Okay, so I'm sharing a new screen. Are you able to see my screen? Which hill station do you prefer?
Yes, sir.
Good. Now, this is a classic example of categorical data. I cannot use Pearson's correlation. But believe me, if you apply Pearson's correlation coefficient, it will give you some answer. Your entire research will become wrong. Your entire research will become wrong. Because men, woman is categorical in nature. This can be called as gender. This can be gender. This can be the hill station. So I have two variables. Both the variables are categorical, and within the categorical variables, I have men, woman, Ooty, Kodaikanal. I have another. This is example number 1. I have example number 2. Pets, gender. I want to find whether there is a relationship between pets and gender. The variable gender and the variable pets, are they related? Are they independent or dependent? Whether there is a dependency between gender and hill station. If you see
No,
the
sir,
data,
no dependencies.
sorry?
No dependencies, about all are independent variables.
I am talking about the dependency between gender and hill station.
No, sir,
Both
no dependency.
How will you tell? What is your criteria to tell that?
It is a preferences actually, like before in previous example we have seen that if number of cigarettes, based upon the cigarette you are smoking, you'll be getting the diseases. Okay, but here it is like a preferences. Whether they are preferring Ooty or they are preferring Kodaikanal, they are nowhere dependencies, sir. They are only preferences now.
Good argument, Karpagapriya. But on the is anybody who is non-Tamil here? Can I speak in Tamil? Is there somebody?
One thing na, when the number of
Tamil,
cigarettes.
we are all only Tamil, sir. You have to speak in Tamil also,
Everybody
sir.
is from Tamil Nadu, somebody from Karnataka, or somebody who cannot understand Kannada, Tamil. Anand Kumar?
Sir, I am only Tamil Nadu. Thiruvannamalai, from Thiruvannamalai, sir.
So everybody understands Tamil, correct?
Oh, correct, sir.
Okay, if there is anybody who cannot understand Tamil, ping me so that, or you raise your hand so that I immediately get back to English. Okay, கொஞ்ச நேரம் முடிக்க போறோம். Another 10 minutes we are finishing. So no, argue பண்ணலாம். இது வந்து எதுக்காக இந்த ப்ராப்ளம்னு சொல்லுங்க ஃபர்ஸ்ட். இது வந்து do you prefer? இப்போ வந்து கற்பகப்பிரியா has said very strongly that both are independent. I am not sure. நீங்க மேல பாருங்க 225. நான் வந்து ஒருத்தங்களை கேட்கிறேன், மேல கேட்கிறேன். நான் வந்து I ask, do you like Ooty or Kodaikanal? I ask random people. We call this as random sampling. I go to men, women. Do you like Ooty? Do you like Kodaikanal? Yeah. One thing we find is lot of people prefer, lot of gents prefer Kodaikanal. Whereas if you look Kodaikanal and Ooty among women, ரெண்டு பேரும் சேமா இருக்காங்க. ஏதோப்பா எனக்கு ஹாலிடே கூப்பிட்டு போங்க, ஐம் ஹாப்பி. அதே மாதிரி நான் வந்து மென் கிட்ட கேட்கிறேன், உங்களுக்கு நாய் பிடிக்குமா பூனை பிடிக்குமான்ட்டு. இங்க பாத்தீங்கன்னா பூனை வந்து கொஞ்சம் பேர் போட்டிருக்காங்க, நிறைய பேர் நாய் போட்டிருக்காங்க. ஆனா லேடிஸ் பாருங்க, எனக்கு வந்து ஒரு பெட் வேணும், அது நாயா இருந்தாலும் பரவாயில்ல பூனையா இருந்தாலும் பரவாயில்ல. Do you agree with this argument?
Yes, sir.
Everybody agrees with this argument?
Yes, sir.
ரொம்ப சிம்பிள். whether you want it or don't want it. இது வந்து எங்க ரியல் டைம்ல எப்படி வரும்னு நான் கேட்கிறேன், உங்களுக்கு சொல்றேன். சரியா? உங்களுக்கு மேக் மை ட்ரிப் எல்லாரும் கேள்விப்பட்டிருப்பீங்க. you have heard about make my trip, கரெக்ட்டா?
ஆமாங்க சார்.
மேக் மை ட்ரிப்ல வந்து என்ன சொல்றான், they sell holiday packages. You can go book your flight ticket, you can book your hotel rooms. They also sell lot of holiday packages. சரியா? How does make my trip a web portal work? He gets commission from the hotel. அப்படின்னா அவன் என்ன பண்றான்னா ஹோட்டலுக்கு புக் பண்ணி கொடுக்குறான், ஃபிளைட் டிக்கெட்ஸ் புக் பண்ணி கொடுக்குறான், கமிஷன் அவனுக்கு கிடைக்கிறது. இப்போ வந்து மேக் மை ட்ரிப், ஐ எம் த கம்பெனி, ஐ எம் த கன்சல்டன்ட், மேக் மை ட்ரிப் கம்ஸ் டு மீ அண்ட் டெல்ஸ் மீ, சார் கொடைக்கானல்ல வந்து எனக்கு வந்து மார்ஜின்ஸ் கம்மியா கொடுக்குறாங்க, அங்க இருக்கிற ஹோட்டல் அசோசியேஷன் வந்து ரொம்ப ஸ்ட்ராங்கா இருக்காங்க, 5% தான் மார்ஜின்ஸ் கொடுக்குறாங்க. அதே வந்து ஊட்டிக்கு போனா எனக்கு 10% மார்ஜின் கொடுக்குறாங்க. புரியுறதா?
ஓகே சார், புரியுது.
சோ இப்போ வந்து if you want to sell, so what will make my trip try to do? They will try to sell Ooty packages only. ஏன்னா ஊட்டி வித்தா அவனுக்கு ப்ராஃபிட் ஜாஸ்தி, கரெக்டா? ஆனா அதுல ஒரு சேலஞ்ச் இருக்கு. By chance if there is a relationship between Ooty and gender and hill station, then whatever as mail I send will become waste. நல்லா யோசிச்சு பாருங்க. நீங்க தினம் காலையில எந்திரிக்கிறீங்க, கூகுள் மெயில ஓபன் பண்றீங்க, என்ன இருக்கு? ஒன்னு ஸ்பாம்ல போவீங்க, ஸ்பாம்ல எல்லாத்தையும் கிளீன் பண்ணிடுவீங்க. பட் வந்து சோஷியல்லையோ அப்டேட்ஸ்லயோ எங்கேயோ வந்து ஒரு மெசேஜ் வருது, ஹெட்டிங் வந்து மேக் மை ட்ரிப்னு இருக்கு. நீங்க மேக் மை ட்ரிப் ஏற்கனவே யூஸ் பண்ணிருக்கீங்க, ஸோ உங்க இமெயில் அவன் வச்சிருக்கான். ஸோ யூ ட்ரஸ்ட் தட் மெயில். ஸ்பெஷல் ஆஃபர் only for you, 2 days 2 nights Kodaikanal, 5,000 rupees only அப்படின்னு போடுறான்னு வச்சுக்கோங்க. If there is a relationship between gender and Kodaikanal and hill station, okay, this matters. இப்போ வந்து let us say there is a relationship, I get a message, make my trip 2 nights 2 days with family in Ooty, 5,000 rupees. But I am a male, at any given time I prefer Kodaikanal over Ooty. எனக்கு வந்து ஊட்டின்னு பார்த்தோன்னே இல்லப்பா ஊட்டி நமக்கு சரி வராது, நம்ம கொடைக்கானல் ஆஃபர் இருந்தா போலாம் அப்படின்னு சொல்லிட்டு நான் வந்து அந்த மெயில ஓப்பனே பண்ண மாட்டேன். ஆமாவா இல்லையா? கரெக்ட். இந்த டேட்டா வச்சு நான் பார்க்கும்போது அது இருக்கு, பண்ணலாம். அதே வந்து நான் ஒரு லேடிக்கு நான் மெயில் அனுப்புறேன்னா ஐ புட் எய்தர் ஊட்டி ஆர் கொடைக்கானல். So it is called as the conversion. The conversion ratio will increase. பட் எனக்கு வந்து இப்போ ஒரு மேக் மை ட்ரிப்ல எனக்கு ஒரு ப்ராப்ளம் இருக்கு. இவன் நிறைய கமிஷன் கொடுக்குறான். எனக்கு வந்து மென் வந்து நிஜமாவே இது வந்து ரேண்டம் சாம்பிளிங் பண்ணதுனால மென் வந்து தெரியாதனமா நமக்கு எடுத்த சாம்பிள்ஸ் வந்து 280 நிறைய பேர் எடுத்திருக்க சாம்பிள் அது மாதிரி வந்திருக்கா அப்படின்னு எனக்கு தெரியாது. இமேஜின் ப்ராபபிலிட்டியில there are 5 red balls, 5 green balls, I pick two balls அப்படின்னு போட்டோம்னா எவ்வளவு ரெட் வரும் எவ்வளவு கிரீன் வரும்னா ப்ராபபிலிட்டி பாக்குறீங்க. அத மாதிரி இது சாம்பிளிங்ல வந்து ப்ராப்ளமா இஸ் வாட் ஐ ட்ரை டு ஃபைண்ட். That means I should find whether there is a relationship. Okay, now Karpagapriya, before talking about they are independent, I'll have to do a test. Correct? இல்ல நமக்கு வேலையே கிடையாது, இல்ல என்ஜினியர்ஸ் வேலையே கிடையாது, நம்மளா சொல்லிட்டோம்னா வேலை கிடைக்காது. எங்கேயோ ஒரு இடத்துல வந்து நான் டெஸ்ட் பண்ணணும். இங்க வந்து நான் பார்த்தேன்னா பியர்சன்ஸ் கோரிலேஷன் கோஎஃபிஷியன்ட்டோ ஸ்பியர்மன் ரேங்க் ஃபில்டரை நான் போட முடியாது. ஐ வில் யூஸ் சை ஸ்கொயர் டெஸ்ட். ஓகே, ஸோ இதுல வந்து ஐ ஹவ் given two examples. ஏன்னா ரெண்டும் பார்த்தோன்னா கிட்டத்தட்ட சேமா இருக்கும். 207, 209, 225, 231, 280, 282, 248, 242 பார்க்க சேமா இருக்கு. ஓகே, பட் இஃப் ஐ அப்ளை சை ஸ்கொயர் டெஸ்ட், அதுக்கு வந்து chi square test is obtained value minus obtained outcome minus or outcome minus expected whole square divided by expected is the chi square formula. அப்படின்னு சொன்னோம்னா இந்த டேட்டா இருக்கும்போது இந்த டேட்டா இருக்கு, நான் ஆட் பண்றேன், டோட்டல் பார்த்தா 962, அது மாறவே மாறாது. இப்ப இந்த டேட்டா இருக்கும்போது ஐ கேன் ப்ரிடிக்ட் ப்ராபபிலிட்டி வச்சு என்னால வாட் இஸ் த ப்ராபபிள் அவுட்கம் என்னால சொல்ல முடியும். ஹவு டு ஐ do that? For this value, this is called as the outcome. ஓன்னு சொல்லுவோம். ஆக்சுவல் டாஸ், காயின் டாஸ் போடுறோம், ஆக்சுவல் அவுட்புட் வந்திருக்கு. எக்ஸ்பெக்டட் அவுட்புட் அப்படின்னு சொல்லும் போது 438 this multiplied by this divided by this, 438 multiplied by 489 divided by 962 பண்ணீங்கன்னா that is the expected output of men preferring cats. அதுதான் நான் இங்க பண்ணியிருக்கேன். I have done. Okay, இத பண்ணா பிறகு I get the answers 1.099, 0.918. இந்த ஃபார்முலா எல்லாம் இருக்கு. I can total it. It is called as the chi squared value. We find something called as degree of freedom. Degree of freedom is rows minus 1 into columns minus 1. Inga 2 minus 1 into 2 minus 1, so it is 1 only. Idhukku vandu there is something called as a chi square table. From this table, it is possible to find whether they are dependent or independent. Okay, I'll tell you idhula vandu enna aidichu aagraduna, hill station and gender are dependent as per chi square test, whereas preference of pets and gender are independent. That means there is no dependency at all. அப்பனா நான் ஒரு பூனையை விற்கணும், ஒரு பெட்டை விற்கணும்னு நினைச்சா நான் வந்து பூனைக்கு நிறைய மார்ஜின் வருதுன்னா நான் எல்லாருக்கும் இமெயில் போடுறத பூனை வாங்கிக்கோங்கன்னு சொல்லி போடுவேன் 90% ஆஃப் இமெயில். சரியா? அதே வந்து இங்க வந்து நான் கேர்ஃபுல்லா இருக்கணும். ஜெண்டர்ன்னு இருக்கும்போது நான் ஜென்ட்ஸுக்கு வந்து ரிஸ்க் எடுக்காம கொடைக்கானல்னு போட்டுருவேன். ஃபீமேல்ஸ்க்கு வேணா நான் வந்து மேல்ல வந்து ரேண்டமா வந்து 70% மேலுக்கு வந்து நான் வந்து கொடைக்கானல்னு போட்டுருவேன், 30% ஊட்டின்னு போடுவேன். ஃபீமேல்ஸை பொறுத்த வரைக்கும் எல்லாருக்கும் ஊட்டி 90% நான் ஊட்டி போட்டுருவேன். ஏன்னா எனக்கு ஊட்டி சேல்ஸ் தான் நிறைய ஆகணும். That is what I do. அதே பூனையோ நாயோ விற்கும் போது it really does not matter to me. It really does not matter to me. So another example where I'm using categorical data using chi square test. Actually, chi square test again is not very accurate. We use chi square test for various reasons. The correct test would be Fisher's test. If I am given the option and know if my client is very fussy about it, I'll do the Fisher's test. But you know, it is all again the fundamentals. What is it we are seeing? Python coding is not difficult. Big data analytics is not difficult. Selecting the algorithm is what is difficult. How to reach that requires a lot of efforts, and that is only data. So that is why I call the data in big data. Yeah, the data in big data is extremely critical. Whether you are an artificial intelligence working in AI, whether you are working in machine learning, whether you are working in data mining, or whether you are working in big data, it really does not matter. The platforms change, the concept, the data remains the same. And if you are not able to select the data, you are lost. Any questions here? Any questions here? I hope this small introduction on the data and big data, not gone into the algorithms. I can speak. It is all jargons. I cannot talk about hyperparameter tuning. I can talk 20, 30 different things which you will not understand in the small period of time. That is why I am asking you to focus first on data, which is not difficult. Descriptive statistics studying here. Practical whenever you see data, always imagine your classroom. கிளாஸ்ல வந்து பசங்க இருக்காங்க, பசங்களோட மார்க்ஸ் எடுத்துக்கோங்க, பசங்களோட வெயிட் எடுத்துக்கோங்க, பசங்களோட ஏஜ் எடுத்துக்கோங்க, பசங்களோட ஹைட் எடுத்துக்கோங்க. 100 ஸ்டூடெண்ட்ஸ் இருக்காங்கன்னு வச்சுக்கோங்க. Do all your analysis there. Try to relate. Skewness ஆகட்டும், courtesies ஆகட்டும், எல்லாருக்கும் கம்மி மார்க் வந்திருக்கு. That means positively skewed. நிறைய மார்க் வந்திருக்கு, negatively skewed. மீடியன் ஏன் யூஸ் பண்ண முடியாது? ஏன்னா 98 மார்க் ஒருத்தங்க மட்டும் வந்திருக்கு, வேற எல்லாம் 30 மார்க் வாங்கியிருக்காங்க. மீடியன் தான் யூஸ் பண்ணணும், மீன் யூஸ் பண்ண முடியாது. ஃப்ரீக்வன்சி பாக்குறீங்க, கரெக்டா? Try to relate to one or two small scenarios so that you do not forget, and do not lose focus on the data. The moment you lose focus on data, you're gone, you're lost out. Okay, your entire research, your entire proposal working is gone. And believe me, as a person who's been conducting or doing interviews for some of the MNCs, some of the top product companies, I will tell you one thing. You all have very good scope to go to the industry if you want to transition. We call it as transitioning. Okay, but provided you build your basics very easily. You need to build your basics. You need to build your foundation. Transitioning becomes extremely easy. Being a person who is already working in the industry and closely working with universities, I can tell you, and being in the interview panel, I can tell you, you can do transitioning. I'm seeing a lot of people taking up transitioning. Okay, if you want to do transitioning, you can start off with some free courses, like not even low cost courses like Udemy. Udemy, you get a course. Okay, or you have Coursera, Udemy, a number of this thing. Khan Academy is free, but maybe it is not very focused. But Udemy and all has some good course. You can start with there, and from there you can try moving to once you are very confident, you can move to the next level, which could be joining doing one of your PG diploma courses from some of the top companies like Upgrad or Great Learning or Edureka. But they all charge you a bomb. They'll charge you about 2 lakhs, 3 lakhs, whatever it is. But as teachers, you can having being good in reading and understanding, grasping the subject, I would suggest you can do it. You have very good scope. And with work from home becoming the reality for the next 2-3 years, ideal time for transitioning, because industry you don't have people. நினைச்சு பாருங்களேன், இண்டஸ்ட்ரியில யார் இருக்கா? உங்களோட ஸ்டூடெண்ட்ஸ் தான். உங்களோட ஸ்டூடெண்ட் இருப்பான், he gets into the industry and he shines in the industry, but his strength and weakness. If you are able to build your strength, you can take it forward. Thank you. Any questions before I close?
Sir?
Yes, Anand Kumar.
Sir, the big data analytics is very much useful in the stock market area also, sir?
Yes, you can use anything, you can use it in any area.
Okay, sir.
Big data is a name. I can come and handle a class for 2 hours talking jargon, which you will not understand at all. All fancy names are, but there is nothing fancy. The foundation is the same. The foundation is the same. Okay, so as long as you understand what is the problem, what is the data, what is the hypothesis. Okay, I don't know, maybe my next session is to the same set of students. If it is the same set of students, maybe I can focus on hypothesis. If you understand this 3, 50% of the battle is won. Then little bit of Python programming and cross skilling. Cross skilling na ஒரு டாக்குமெண்ட்டை படிச்சுட்டு உங்களால நீங்களா கோட் எழுத என்ன செய்ய சொல்றான்னு புரிஞ்சுக்கணும். Application of algorithms, whether it is a Bayesian, எல்லாம் ரொம்ப simple. See, I've taken covariance, I've taken chi-square. Analysis is more important. Getting the output. இப்போ நம்ம எக்ஸாம்ல அவுட்புட்ல மட்டும் தான் இருக்கும், ஃபோக்கஸ் பண்றோம், விட்டுடுறோம். analysis is important, and if you are able to do that, you can succeed.
Okay,
So
sir.
yes, it can be used in any field, stock market or medical, wherever it is, you can use it.
Okay, sir. Thank you, sir.
Any other questions before I close? Thank you all. Then over to Dr. Geeta. Dr. Geeta, you are here.
Yes, sir. Yes, sir.
Thank you.
Okay. If, participants, if any queries, or shall we conclude? Okay, sir. Shall we conclude, sir?
Yeah, can I drop or should I be there in the?
Sir, be here, sir, please. Be
Okay,
there,
sure.
sir.
No problem. Yeah, absolutely.
So, very good afternoon to all participants. So, today our resource person Madhu sir have explained about big data analytics with more examples. I think today the session is somewhat interactive. Sir have explained various algorithms of data analytics and how to analyze the data, and also clearly explained each and every derivations with examples. And Sir have tell about the opportunities in big data analytics and the importance of analysis and output. So we have to thank our resource person to be with us in his busy schedule. So thank you, sir. And
Thank you.
also on behalf of Department of Computer Science, Excel Engineering College, we thank our resource person. Thank you, sir.
Thank you.
And I thank all the participants to conduct this today's sessions in successful manner. And kind request to the participants, feedback link is given in the chat box. So please submit the feedback without fail.
Thank you, madam. So shall I drop?
Okay, sir.
Thank you very much. Thank you all. Bye bye. Thank you.
Thank you, sir.